Need for error coding. Data transmission errors occur in terrestrial mobile communication due to multipath fading, diffractions or scattering in cellular wireless communications, low signal-to-noise ratio, and limited transmitted power and energy resources in satellite communication. Error coding uses mathematical formulae to encode data bits at the source into longer bit words for transmission. The code word is then decoded at the destination to retrieve the information. The code word consists of extra bits, which provide redundancy, and at the destination, it will decode the data to find out whether the communication channel introduced any error, and some schemes can even correct the errors so that there is no need to resend the data. There are two ways to deal with errors. One way is to introduce redundant information along with the data to be transmitted, which will enable the receiver to deduce the information that has been transmitted. The second way is to include only enough redundancy to allow the receiver to detect that error has occurred, but not which error, and the receiver makes a request for retransmission. The first method uses error correcting codes and the second uses error detecting codes. Consider a frame having data bits, message to be sent, and redundant bits, used for checking. The total number of bits in the frame will be nm plus r, which is referred as in-bit code word. Consider two code words, 11,001,100 and 11,001,111, and perform exclusive OR and then count number of ones in the result. The number of bits in which the code words are different is called Hamming distance. Suppose the code words are Hamming distance d apart, it will require d single bit errors to connect one code word to another. The properties of error detection and error correction depend on the Hamming distance. A distance, d plus 1, code is required to detect d errors because d single bit errors cannot change a valid code word into another valid code. Thus the error is detected at the receiver. A distance, 2d plus 1, code is required to correct d errors because the code words will be so apart that the transmitted code word will be still closer than any other valid code word, and thus the error can be determined. A distance, 2d plus 1, code is required to correct d errors because the code words will be so apart that the transmitted code word will be still closer than any other valid code word, and thus the error can be determined. A distance, d plus 1, code is required to detect d errors because d single bit errors cannot change a valid code word into another valid code. Thus the error is detected at the receiver. A distance, 2d plus 1, code is required to correct d errors because the code words will be so apart that the transmitted code word will be still closer than any other valid code word, and thus the error can be determined.